Now, as I've mentioned before, the kidneys are kind of the king when it comes to regulating blood pressure. This is because blood pressure is tied in many ways to blood volume. And very few parts of the body have as much control over blood volume as does the kidney. Now, the kidney also has some specialized receptors found near the glomerular apparatus or around the glomerular apparatus that we're going to call the juxtaglomerular apparatus or the JG apparatus. Its main job is going to be to help regulate the filtering of the blood and how much of that filtrate we are producing and the things that are in it. But as well as kind of a byproduct, or really as a primary goal, to help us regulate systemic blood pressure. Now, we're going to be doing this by regulating blood volume, but also by secreting some chemicals that their job is going to actually be to increase blood pressure. Now, we know that the enzyme that we are going to excrete from the kidneys that is going to raise our blood pressure is going to be renin. We know that this is part of what we had as part of the blood pressure chapter as the renin-angiotensin-aldosterone system, where renin gets secreted, and this is going to convert angiotensin, which is found in the blood, into angiotensin 1, which will then get converted by our ACE enzyme, so angiotensin converting enzyme, into angiotensin 2. When that happens, that is going to stimulate our thirst centers to tell us to drink more. It's going to constrict our vessels, raising our pressures. So it's going to raise our blood pressure. It's also going to tell us to not get rid of as much water. So we're going to keep blood volumes high. We're going to drink more water. So we're going to raise blood volumes even higher. And we're going to be constricting the vessels, once again, raising blood pressures even higher. So renin is a very powerful chemical for doing this, but it makes sense that it's created by the kidney, thus the name, the part ren in renin, but also because this is a great plus for us to measure and manipulate all of these things. Now, one of the first main cells in the juxtaglomerular apparatus is going to be the granular cells. Now, these granular cells are some modified cells here in the afferent arteriole. So here we have the afferent arteriole, and it's going to be surrounded by these granular cells. Now, what these are basically, like I said before, modified smooth muscle cells. So as these smooth muscles get stretched out a little bit, they're going to then signal to say, hey, blood pressures are high. Or they can be stimulated to contract a little bit to kind of constrict this and make the afferent arteriole smaller, lowering some of these pressures. Now, we're also going to see these cells are the ones that are actually going to be secreting renin. Like if they feel that they aren't being stretched as much as they're supposed to, well, if that means that blood values are kind of low, that means we need to bring all of these things up. So if we need to bring all things up, they will secrete their renin so that we can raise blood pressure, so we can get more fluid in and hold on to that fluid to elevate our blood pressure and keep our blood pressure at a higher level. That way it can work a little better. Now, we also have here the macula densa cells. You'll notice here that it says DCT. That's because this is a distal convoluted tubule of the nephron. Now, it is going to be lined by some special columnar looking cells that we're going to call the macula densa cells. What these are doing is these are actually measuring the amount of salt here in this particular part of the distal convoluted tubule. So we are measuring the amount of salt here, which basically means we're measuring the concentration of the urine. And if that feels that these numbers are not concentrated enough and that we should be holding on to some of this fluid, they can then release some hormones and through paracrine stimulation tell the granular cells to start raising our blood pressure, stop eliminating stuff as urine, raising the blood pressure so we can push more fluid out, all of these kinds of things, all through these two little bits. So through the granular cells in the afferent arteriole and the macula densa cells of the distal convoluted tubule. Now, we also have these special cells found in the space between the macula densa cells and the afferent and efferent arterioles that we're going to call the extraglomerular mesangial cells. However, their particular functions in this system aren't really well known.